getting descriptive in describing a particular situation accurately. The third type of research is diagnostic research. And in diagnostic research, what we try to do is we try to determine the frequency with which something happens and the degree of association of that particular event with something else. So most of the research that we do here, either in economics and extension, economics particularly, fall under the category of diagnostic research or hypothesis testing research. So in diagnostic research, what we usually do is we try to find correlates with a particular phenomenon, and we try to explore relationship between one particular variable. For example, we can say technology adoption and the socioeconomic characteristics of the farmers. This is something that we often do in diagnostic research. And when we come to hypothesis testing, we often try to test a hypothesis, and usually it is about a causal nature. A cause or effect relationship is usually being explored. Or in some cases, for example, we want to check whether the income of dairy people practicing monocropping and diversified farming or mixed farming is different. So in those things, we also go for testing our particular hypothesis, and the objective is to get that particular estimate of that. So moving on to the different approaches to research. Broadly, we have four approaches to research. One is the quantitative approach, the other is qualitative. We have mixed methods and action-oriented research. So let me start with action-oriented research, especially in our Krishi Vigyan Kendras. What we try to do is the research is more or less action-oriented in nature. The key target we have here is to solve a pressing need in that particular community or educate for example, it is technology dissemination or dissemination of information regarding a particular technology. Now coming to the mostly used approaches, one is quantitative and other is qualitative. Quantitative approach is usually used in cases where it can be measured. The data can be measured and you can express in terms of numbers. So basically here what we have is we have a top-down approach, and the main objective is to is confirmatory in nature. We do have a hypothesis that is, and we focus on using data to test a particular hypothesis. For example, if we have we have an information that diversification leads to increase in farm income. We try to test that empirically in terms of quantitative analysis. So in this, what you have is you have a hypothesis which is very general, and from the general we move to a particular statement. And you usually follow a deductive reasoning approach here. Next case, what we have is the qualitative research, and this is more common in the case of extension rather than in economics. Economics is more data oriented, and we have more of it is dominated by quantitative techniques. In extension, we have a bottom up approach here. The key here is to find is to generate new knowledge or new insights in qualitative research. So in this case, we have an inductive reasoning. We go from a particular to a general case. So most of this qualitative research is done in case of extension discipline as compared to economics. Same consideration when you have a descriptive or exploratory study of how diversification improves the welfare of the farmers or how it leads to greater knowledge levels, then we have a qualitative dimension to it. And we have mixed methods where we have both confirmatory and explanatory methods. We use both quantitative and qualitative methods, and here we try to get a complex explanation of try to elicit pathways through which that particular action can be completed, or that particular in case of impact, we try to elicit the different impact pathways. So what usually happens in mixed method is you start with quantitative data on one hand, and then you try to validate that with some qualitative observations. So this will give us a more holistic view, and mixed methods are considered to be slightly superior because you get the best of both parts. Okay. Now, looking at quantitative research, because most of the research in case of economic field is quantitative in nature, we have three approaches. in quantitative research or data-based research, we have the inferential approach, the experimental approach, and the simulation approach. Most of the studies that we do involve either correlation or regression. Uh, these studies are known as inferential studies. Like you take the data which was collected for a particular purpose and we try to develop relationship between different factors, and we try to infer regarding a population based on a sample. So this is what basically an inferential approach of research is. Here we are more concerned with analyzing the uh, looking at the relationship or association between variables. An inferential approach, one of the major weaknesses that we have is we do not have control over all the covariates in the study, or like all the dependent variables. For example, we want to look at factors that influence farm income. In the case, there will be n number of factors that influence the farm income. For example, diversification could influence that, your land size could influence that, the technology that you use, it could influence that, your factors, whether you are going for a rain-fed cropping or an irrigated farming, it could influence that. So there are n number of factors and we do not have control over many of these factors. So we have some problem which I'll explain later as confounding in case of inferential research. In inferential research, the problem is we cannot get a cause and effect relationship directly or accurately. There might be biases in that. The second approach that we have is experimental approach, which we see more in the case of basic sciences like agronomy or in genetics and plant breeding. Genetics and plant breeding, we have that. Most of those, they have experimental approaches. In this particular case, what we have is that you have experiments where you have the ability to control for the other factors to a great extent. Okay, like in experimental approach in a field research, plot level research, what we do is we give particular treatments, and you have a treatment group and a control group, and you can actually get the effect of the treatment. You can segregate the effect of the treatment accurately. In simulation approach, what happens is, this is something that is usually used in climate change research. You create an artificial environment, and then you try to understand what are the effects of some of the variables that you change. This is what you do in simulation research. So am I clear till now? Hello? Hello?
Yes, sir.
Okay. So any
Yes,
doubts?
sir.
Any doubts regarding these approaches? Okay, I hope that it is clear. So let us move to the next topic, which is research methods versus research techniques. What are the differences? So research techniques are instruments used in performing a particular research operation, like making observation, recording data, techniques, or processing data. Whereas research methods are instruments used in selecting and constructing research techniques. So I would like to make it more clear with the help of an example. So in case of field research, we have different research methods like participant direct observation. So participant direct observation is a research method wherein the researcher that becomes a part of a particular community, and he observes their actions or their behavior. This is commonly used in psychological research. So in this case, what we usually use is life histories. We use interactional recordings. We make use of photographs or video recordings to in this particular research method. Similarly, more common cases, personal interview is a research method where we try to elicit information from the farmers, and here we try to use either interview schedules or questionnaires. So I hope that the difference between research method and research technique is clear, right? Okay, now coming to the scientific method of research, there are few key components to a scientific method of research. One is it relies on empirical evidences. Second, it utilizes only relevant concepts. Then, most importantly, it is based on objective considerations. So objective consideration means there is minimal amount of researcher bias or subjectivity towards research. It is more neutral in perspective. Then aims at making adequate and correct statements about population objects. It results in probabilistic predictions. So you might be able to predict things. And the methodology used is available to the public for scrutiny. So basically, good research, what happens is you publish research papers, right? In that case, you have it peer reviewed. So it is available to the public how you have done the research, and they are free to comment on it, and you can improve on the research that you have already done. Then then the most important thing that we have is a research conclusion can be tested through replications. So in a case like, suppose I do a study on particular effectiveness of a drug. So if someone else also does the same study, that is he replicates it, he should get similar results from that, provided that the conditions, the experimental conditions are similar. So if you do that study again, you should get similar results. This is very important. Like in this case, what happens is the possibility of that particular intervention having an effect, or that drug having a positive effect, it will be due that the effect being due to chance will be very less if we have uh, if we have the possibility of testing through replications. So the third important is in the research, it generally aims at formulating general axioms which can be used to develop popular theories. Okay. Now the key area of my talk, or the key concept of my talk, which is the research process. So what is a research process? Research process is basically the sequence of steps that has to be followed for scientific conduct of research. Okay. So I'll just give a brief intro into all these steps. I think you are familiar with it, right? Hello? Hello, am I audible?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah,
Yes,
okay.
sir.
This figure you might have seen in Kothari book. So Kothari and Garg, there is a book on research methodology written by Kothari and Garg, and it is a very useful book. It will give you a very good idea, and it is very crisp also, and given in a very simple and easy way. So I would recommend that book to you. It is very easy to read, and I think everyone should read that particular book, because all the concepts now they have explained it in a very simple manner. So first step in a research process is defining a research problem. So we need to have a particular problem that we address. So like, say, how can we double farmers income? That is the research problem. Now the second step what we do is, how can we do, how has been that how that particular research problem has been addressed in previous literature or previous studies. So what happens is, most of the time what we do is we review research findings of previous studies, like how a particular if our objective is to look at how a technology has been adopted, or what factors have influenced the adoption of a particular technology, we go to the websites, we go to the internet, or we refer through journals, and we mainly focus on the research findings of previous studies. For example, our research problem is factors affecting the adoption of drip irrigation. So most of the time what we do is we go out there and we look at studies that have looked at that have tried to assess the factors which have led to adoption of drip irrigation. But there is another aspect also to it, where we review theories and concepts. So for adoption, so the in extension you have a theory of adoption, right? So what are the factors that influence adoption? You have a theory of adoption. So basically, one thing additionally which we have to review is the theory regarding a particular the general problem that we have in place. Then what, after review, what we do is we convert the research problem into a hypothesis. A hypothesis is a tentative assumption which we have to check. For example, drip irrigation adoption is correlated with availability of irrigation facilities or irrigation tanks, some structures. This is basically a hypothesis which we would like to test. Okay, then the next step is to go to a research design, to develop a research design. That is a plan of conducting the research, how the research has to be conducted, how data has to be collected, how data has to be analyzed. We need to have a predetermined plan for this. In this way, we will be having a research design. Okay, then what we have is the fifth stage is collection of data, or that is the execution of research. We can employ various methods for collection of data. I'll be describing them in detail. And once the data is collected, we will be analyzing the data, and basically we will be testing the hypothesis. Our hypothesis was access to some kind of irrigation structure is essential for the adoption of drip irrigation systems. And after we have analyzed the data and we have our findings, we will interpret the results and report it. Okay, a report can be in the form of if it is your thesis, you will be having the thesis. Maybe you can get a couple of research papers out of it. Okay, so you have a feed forward mechanism and a feed backward mechanism. So all these processes are interlinked. Like once you go to the data analysis part, okay, your data analysis will be dependent upon the research design you have collected. And once you have analyzed the data that you have collected, and some cases you don't find the results to be satisfactory, what you do is maybe you just look at how the data was collected or the execution of data collection. Okay, execution of data collection. If there has been some errors there, we try to rectify it and go back. Same thing that we do is once we try to interpret the results, they are not satisfactory, we go for a different method for data analysis. Okay, so this research problem, and again if you go to the reporting of the findings, maybe this will have a feedback loop to the next research problem which we are going to have. Okay, I hope I'm clear, right? Now, now what is a research problem? A research problem is a statement about an area of concern, a condition to be improved, a difficulty to be eliminated, or a troubling question that exists in scholarly literature, in theory or in practice, that points to the need for meaningful understanding and deliberate investigation. So so a research problem has four components. One is the objective to be attained. It should have an objective. Our research problem, there should be some objective to be attained. Then there should be alternative methods to attain the desired objective. Okay. And the alternative methods that we have, like for example, if it is increasing productivity of wheat or some crop in Maharashtra or of red gram is the objective. There are several ways of doing that. Okay, and different ways should also have different relative efficiencies. So some method might be more easier to attain than others, and these methods, or the efficiency of these methods and the objective to be attained, they will be within a framework of an environment. That is, a particular region or a particular place should be there where this research problem is applicable. Okay, under certain conditions it is applicable. Now, while defining a research problem, the following techniques have to be employed. The first is we should state the research problem in a very general way. So our research problem could be increasing the productivity of wheat or increasing wheat yields is a general statement of a research problem. The second case is understanding the nature of the research problem. Herein what we do basically is we go into the literature, we speak with experts, and we try to understand what is the cost behind that particular research problem. And for understanding research problem, we have two techniques. One is surveying available literature, and the second is developing ideas through discussion. And once we have done both these things, what we do is we rephrase the research problem into a more specific statement. For example, how to increase the productivity of wheat in Punjab, or how to increase the productivity of wheat in irrigated regions of Punjab. We will have a specific research problem. And the second thing is we will have a specific time period. We will have a specific objective there. So that is basically the research problem. And some things which we have to consider while defining a research problem is the technical terms should be clearly defined. Like, for example, yield or productivity, we should define whether it is a total factor productivity or yield which we are looking at, that is per hectare productivity. Okay. Then the basic assumptions to the research problem should be clearly stated. This is something that we often do not do while we run a model. Like yesterday Bishujit might have uh, uh, would have taught econometrics. Okay. So the assumptions of the OLS model, they used to state it clearly. That is a technique that can be used to understand the association, the relationship between different variables. So in that case, they have clearly stated the assumptions of that particular OLS regression model to estimate the regression coefficient. Similarly, while you are stating a research problem, we need to clearly specify the assumptions that we have. Then uh, straightforward statement of the value of the investigation should be provided. So this is basically why you are doing that research. It should be stated. Uh, it should be stated explicitly, and what is the potential benefit from it. Then suitability. The next thing that you should look at is whether the data you have or the sources of data you have are suitable for analysis or addressing that particular research problem. And one thing that we all know is that no research is always perfect. So there might be some limitations in our study. So that limitations should also be clearly mentioned. Okay. Then the next step is formulation of hypothesis. So what is a hypothesis? Hypothesis is a tentative assumption made in order to draw out and test its logical consequences. Hypotheses can be developed through discussion with experts and colleagues, examination of data and records, review of similar studies, and preliminary field investigation or personal exploratory studies. So this is where, from the point where we start narrowing down our research. So basically, we had a research problem at hand at the beginning. Now we are narrowing it down to a hypothesis which we would like to test. Okay. So in case of, for example, doubling farm income, they have given several strategies. One of them is diversification. So we want to test the hypothesis whether diversification leads to higher income. Okay. So we want to test this hypothesis. So we will, next step, we will look for a research design which is suitable for that. So what is a research design? Research design is an arrangement of conditions for collection and analysis of data in a manner that aims to combine relevance of research purpose with the economy in procedure. So it is a way of attaining the desired objective, that is testing of the hypothesis with least possible cost, that is economy of procedure. So with least possible cost, we try to uh, attain that particular objective. So research design has the following things. It specifies the source and type of information relevant to research problem. So if you are looking at whether diversification can lead to higher farm incomes, you can either be looking it through secondary data, which is available already, or you can go for a field survey and collect primary data for that. It specifies what approach will be used for gathering and analyzing data, same that we have explained, discussed here. How data will be collected, how it will be analyzed. So when it comes to sampling, how that sample will be collected. Those things we will be explaining in the upcoming sessions and upcoming slides. And the next thing is, what is the time period that is required and the cost estimates. These things also we have to do. Right now in our research program, basically, as students, we don't do these cost estimates, but while writing some project and all, we have to give the particular estimates and the period of project that we have. Okay. Now, the components of research design, this is important. There are four major components of research design. One is the basic one. If we are going for a social science study, we go for the sampling designs because we go for surveys basically, right? It is impossible to survey an entire population. That is a census. It is a very laborious process. It is very time taking and it is very expensive as well. So we go for surveys where we select from a subset of the population, general population under consideration. We have a sample. We select a sample, and then based on that particular sample, we make inferences regarding the general population. Or in some cases, we go for a particular sample and we go and do a case study, which is not generalizable. That is for that particular sample itself, or that particular village. If you are looking at a village where a particular intervention has been taken, like a watershed intervention, so we can go out there and do a case study there where we specify about the different aspects in that particular village or in that particular project, what has happened. That is a case study approach we can have. So both cases, most of the time we do not enumerate the entire population. What we do is we take a sample, and so sampling designs basically looks at how the sample is collected. Okay. Then we have observational design. This is basically done in the case of experimental research, where the condition under which observations are made. Same thing we can do in social science also. We have stated preferences and revealed preferences. So in under what conditions do we go for data collection? Like we have some experimental methods in economics, especially where we make use of this observational design. We give certain conditions under which that particular individual is observed. So when it comes to the observation method of data collection, I will just explain that. Okay. Then statistical design, this is about how the data is gathered and how it can be analyzed. And then we have the operational design, in which how all these three designs have to be executed. Okay. So the concepts of some concepts of research design, this is important. This could be important from your research perspective, also from your exam perspective. So once we try to look at causal effects between what are the effect of A on a particular variable B. For example, if you have started a new intervention program, like providing high quality seeds. So what is the effect of that providing high quality seeds on farmer outcomes? Like on the outcome or outcome, which is farm income, maybe we can look at that. So what happens is that we can never say that the only factor affecting farm income is the availability of quality seeds. There might be factors regarding the availability of other inputs. There may be other institutional arrangements. You might have tenant farmers and you might have landowning farmers who have different levels of income. So these variables, these are all independent variables that are not related to the purpose of the study, but may affect the dependent variable. So any factor other than the particular factor which we are trying to look at is which we are trying to look at, those variables are basically extraneous variables. So this term has been used more in case of experimental research methods. So any independent variable that can have that could potentially have an effect on our outcome variable is an extraneous variable. So what we do is, to minimize the extraneous effect of extraneous variables, we bring in controls. For example, in case of our experimental research methods, you might have studied in your BSc Agri, you have a treatment plot and a control plot, right? In one plot, you give a particular treatment, and in another plot, you do not give the treatment. So what we try to achieve is that the treatment and control units, like the treated population and the control population, are to a great extent similar in nature. So that is what we try to do. And confounding relationships. These confounding relationships are conditions wherein the dependent variable is wherein the dependent variable is affected by the extraneous variables. Okay. So confounded relationship is a condition wherein the dependent variable is affected by extraneous variables other than the independent variables. Okay. So I just made a slight mistake here. It is not free from. It is not variable is not free from the effect of extraneous variables. It is a condition wherein our control is not perfect. And another kind of problem that we encounter in case of specifically regression analysis, which economic students might be familiar, is endogeneity bias. So in this case, what happens is that you try to suppose you want to see the effect of a variable, for example, say education of the farmer on his income. So what we do is we run a regression to test the relationship between education and farm income. So there might be n number of variables which can affect the farm income. So we include those variables which we consider to be important in this x, which is a vector of all the independent variables which we consider to be important. Now suppose that motivation is a major factor which will affect a farmer's income. Okay. Many a times measuring motivation is very difficult, so we have dropped that out. So what happens is that the effect of motivation will be subsumed in this error term. Okay. So while running a regression, if the x variable we have, for example, the education that a farmer receives or the number of trainings a farmer has attended, it might be highly correlated with the motivation level of the farmer. So if your error term is correlated with your independent variable, it might lead to some effect on the y variable here. Okay, that is farm income in our case. This is something that we call as endogeneity bias. So the effect that we estimate with the help of this regression coefficient b here, it might not be correct. It might not be true. So biasness, I will explain it in the later slides. Okay. Hello, am I clear till now? Hello.
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Okay. So now we are going to different types. I had mentioned about different research types of research which we had based on the objective. So one is exploratory research. So in exploratory research, what we try to do is, it is basically what we do there is we try to gain new insights. It can be used for preliminary field investigations, like before submitting your synopsis or some synopsis, you might go to the place where your research is going to be conducted, and you try to get a brief idea about what is happening there. So this is basically one kind of exploratory research design. So because of the limited availability of information to us, because we haven't been there before, or we don't have a complete idea of the problem, or we do not have a fair idea of the problem, we can go for a flexible research design. And most of the time the sampling that we use is non-probability, because you want to get an understanding of what is happening there. So you go for something like convenient sampling or haphazard sampling. Whatever person we are able to meet, maybe the village head, we might go to him and we will ask, we will get a fair idea about the situation from here. There is no pre-planned design for analysis, and the data construction, the instruments for data collection might be unstructured. Like when you go for data collection for your research, you will take a structured question schedule with you. You will be having a schedule, right? There is an order in which the questions has to be asked in there. Okay. So that is how we look at. You have a structure, there is a clear plan on how the data has to be collected, what question has to be asked. But in exploratory research design, we do not have a structured instrument, because our objective is to get some insights in that. Then the third is, there is no fixed decision about the operational procedure, how we are going to go about it. We only have a vague idea, it is not very fixed. But when we go to descriptive or diagnostic research design, what we have is we have a rigid research design. All our units which we are going to select are based on probability sampling methods. So I'll just explain what is probability sampling and non-probability sampling. In probability sampling, what happens is that the chance of a particular individual being selected is known to us. You can calculate that chance, or that chance can be, a probability can be estimated. But in non-probability sampling methods, we cannot estimate the probability of a person being selected. Okay. Then we have a pre-planned design for analysis. We use structured instruments for data collection, and advanced decisions are made regarding the operational procedure in advance. Like beforehand itself, we know what is to be done, and those things are clearly mentioned to the enumerator or whoever is doing the analysis. Okay. Now, when it comes to hypothesis testing research, again, we have three types of methods that we use. One is the experimental method, quasi-experimental method, and non-experimental methods. Okay. So you might be using regression analysis or correlation analysis in your study from surveys based on survey data. Okay. These are basically what we call as non-experimental methods. So as I mentioned earlier, in non-experimental methods, we have very limited control over what we call as extraneous variables. Okay. Am I clear? Hello? Okay. Okay, I hope I'm clear there regarding non-experimental methods.
Yes, sir.
Yes, sir.
So you don't have any control regarding the extraneous variables. So it is very difficult to ascertain causality. Like that is the cause and effect. Like suppose you see that large farmers have larger incomes in a particular region, but you cannot say with surety that large farm size will lead to larger incomes, or whether the larger farm size is the cause for larger incomes, and to what extent farm size will have an effect on farm incomes. We cannot estimate that correctly because there might be several other factors which might confound the effects, as we told earlier. Okay. So because of these limitations of methods like regression or correlation analysis, they give only association or correlations between variables. Okay. In terms of simple correlation analysis, what we have is we are seeing the relationship between variable A and variable B. We do not control for any of the variables. In regression, we are able to control for some of the variables to some of the variables. Like you have more than 2 or 3 factors, so we'll be able to control for that factors to some extent, but we won't be able to control for unobserved characteristics. Okay. Coming to quasi-experimental methods, these are being used more recently. Like you have propensity score matching, you have regression discontinuity analysis. What we try to do is once the treatment has already happened, for example, we want to look at the impact of PM Kisan Yojana or something. The thing has already been conducted, like the intervention has already happened. So we will try to compare the two groups which we have access to, who have access to PM Kisan and those who do not have access to PM Kisan, and we will try to select the population in such a manner that they are similar, and the similarity is judged based on observed characteristics only, like whatever factors we can observe. Like we have several several variables uh, of the treated and control group, and we try to make them as much similar as possible. So in propensity score matching, what we do is we just match the different uh, the people in the treatment and control group, and we make a small subset of this where the treatment and control group are similar and they are comparable in nature, but they are not exactly comparable because we are making use of observed characteristics only. When it comes to experimental methods, like you might have heard of Abhijit Banerjee and Esther Duflo, they got the Nobel Prize last year. So they make use of a technique known as randomized controlled trials, where each treatment is allocated randomly to the is allocated randomly in such a manner that your treated treatment group and control group are comparable in nature. Like the treated and controlled population, they are selected using random sampling. So what we can say is that on average, most of the times the treated and control group are likely to be highly similar to each other. So this is where we go for experimental methods. Okay, I hope the difference is clear. Okay, now coming to principles of experimental design, we have the principle of replication, the principle of randomization, and principle of local control. So principle of replication means it is a way of increasing the accuracy of our estimate. Because if you do an experiment once, you might get a result. If you do it twice, thrice, you will be able to get more accurate results. Because the first time, maybe if you, for a even simple example, if you, there are high chances of errors in experiment happening. So what we do is, once we do one or two replication, what happens is that the chance of error gets less, like human error will be less in that, and we will get more accurate or precise, more accurate estimates from replication. So same treatment we will be giving multiple times. Okay. Then the second is the third one. I'll explain the principle of local control. When we go for field experiments, what we do is we have a treatment group and a control group in such a manner that we think that the control group and treatment group are similar. Okay, so we have a control where and we have a treatment. So the only difference between the two will be that one has been given a treatment, the other has not been given a treatment on the field. So in a random RCBD which you have studied, if there is fertility variation, what we do is we go for blocking. In blocking, what we do is we get blocks where the fertility levels are similar. Okay, so they are exactly comparable. So maybe there are 3 levels of fertility. So we go for 3 levels of blocking there. We have 3 blocks, and in each block, what we have is each block, the plot that we have will be similar. So we try to give for local control in such a manner that the treated group and the control group are similar. And the second principle is randomization. In randomization, what we do is we allocate the treatment randomly. Okay, so that each unit has an equal probability of getting a particular treatment. This is the principle of randomization. So I hope I am clear. So the first one tries to get a more accurate result, and principle of randomization and control, they are trying to reduce the error term. That is, the source of variation is by chance. We are trying to reduce that to a minimum using the principle of randomization and control. So to extract the effect of a particular treatment, we do that. Okay. So some of the next I'll explain some of the experimental designs which we have, the formal and informal, some of the informal experimental designs which we use in social science. Okay, so suppose you want to see the effect of a particular program which was introduced in a year. Say in 2016 we had very recently we had the PM Kisan Yojana launched. So we want to see what is the impact of PM Kisan Yojana on farm incomes or technology adoption, maybe we can see. Because at the time of harvesting, they release around 2000 rupees, which they can use for purchase of fertilizers. Or so maybe we can look at what is the impact of PM Kisan Yojana on adoption of good quality seeds. That is, so what we do is we take the control group, that is people who have been beneficiaries of Kisan Yojana, and we look at the control group who are not beneficiaries of Kisan Yojana, and we take the difference. Basically, that is sorry, this is before and after. So what we do is, before PM Kisan Yojana, we ask them what was their adoption level, and after PM Kisan Yojana, what is their adoption level, and we take the difference. Okay, this we attribute as treatment effect. But what happens here is, between the launch of the PM Kisan Yojana And before the launch of PM Kisan Yojana, many things might have changed. For example, the KVK, for example, uh, in that particular village, the KVK might have had a new program there where they might have supplied the seeds, and because of that, because of the KVK program, they might you can see that in treated group there is higher adoption. So what happens is with here we are not controlling for what we call as extraneous variables. Okay, so the treatment effect might have there is larger chance of having extraneous effects there. Then one thing how we can control is that, okay, uh, we can look at different cross section. Okay, what we will do is we will look at people with access to PM Kisan, without access to PM Kisan. Okay, and we will take the difference in adoption or in farm income of people with and without design. This is basically with and without design. So with PM Kisan, without PM Kisan, what has been the real levels or what has been the level of adoption of technologies. So here what we have is here again the Y minus Z, those with after treatment, those without treatment we will be looking. So PM Kisan has been introduced, we will be looking at beneficiary and non-beneficiary. So what has to be one of the basic assumptions we have here is that the treated and control group are similar or they are identical. To be very precise, they should be identical. Like if you should have a possibility of farmer with PM Kisan, same farmer without PM Kisan we should have, but that is not really possible in our studies. So when we go for a different when we go for our control group, what happens is that the treatment and control group may not be identical in nature. There may be many other differences. So these variables will again have a confounding effect. Okay, so suppose those with access to PM Kisan are people who are more educated or who are more informed. They have better social networks. Now, those people without access to PM Kisan have poorer social networks. So, what happens is that if you have a good social network, it is highly likely that you will be able to adopt new technologies quickly, like getting seeds. Maybe the seeds are being distributed in the local Krishi Bhavan. So, people with good networks will be able to get access to that particular uh, seed more easily than uh, people without good social networks. So social network is a factor which we are not controlling for, and this might bias the have a bias on the impact of a particular scheme. So with and without control has a problem that the treatment and uh, sorry, the treatment and control groups may not be identical. Before and after design has a problem that at the 2 points of time the same thing might not that 2 points of time there things might not be identical, which could lead to some extraneous variables or confounding errors. So here what we go for is before and after with control design. This is more applicable, more practical way of looking at things. So you have a treated group, we have a control group. Okay, so we have data regarding time period 1 and time period 2, that is before treatment and after treatment. Once the program was launched, so what we will do is we will take the difference between time period Y and X, that is between the two periods for the treatment group, and we will take the difference between the two periods for the control group also. So for the treatment group, the difference is Y minus X, and for the control group, it is Z minus A. And our treatment effect will basically be Y minus X minus Z minus A. Okay, this is what we do in what is known as difference in difference method. We have what you call as a panel data, that is data of the same cross section over two different points of time, and we will just take the difference between y minus x and z minus a. We will take the difference. Two times we will take the difference. That is the difference before and after, and the difference between control and treatment. So the difference between control and treatment will be taken after adjusting for difference in time period. Okay. So in the this is a more practical design of experiment, and this is to some extent quasi-experimental in nature. But we also have a limitation in this design where we say that it's called parallel trend assumption. That is, we will assume that the treated area and control area will be moving in the same direction or at the same rate. For example, if I am checking uh, using the diff and diff, for example, wheat productivity in Punjab and say some place like Western UP. So in Western UP, what happened was that there has been a surge in productivity on wheat yields, whereas Punjab the yields have stagnated. So here this parallel trend assumption might not hold. Like yields need not be going, like yield need not be the following the same trend in both the periods or in both the places. So in that particular case, this particular method might lead to some kind of confounding error as well. So once the parallel trend is not satisfied, we cannot exactly use this before and after control might also give biased estimates. Okay, now moving to the case of sampling design. Sampling design is a definite plan for obtaining a sample from a population. Why do we prefer sample surveys over census surveys? So the reason for that is census is very expensive, which is one thing, and it is very difficult to conduct. And one more thing is the difference is the sampling versus non-sampling error. Once you go for a census, there is more chances of making mistakes, which we call as non-sampling errors. So what is sampling error is we are taking a sample, and based on that sample, we are inferring about the population. This might lead to erroneous results this might lead to erroneous results, and this is basically known as sampling error. Okay, but the good thing about sampling error is based on the sampling design, we can have a accurate estimate of what the sampling error can be. But in case of non-sampling errors, like uh, while entering the data, there is a mistake. There is no probability which we can attach to it, or the chances of non-sampling error we cannot attach to it. So what it is better to go for a sampling because you know what is the probability that you will make a mistake. Okay, then the objective of sampling procedure is to ensure a relatively small sampling error. So that is the basic objective of a sampling procedure. And before going for sampling, one thing we should have, that is the sampling frame. That is the list of all sampling units in a sampling universe. Suppose you are going to uh, take a sample of farmers in Maharashtra. So you need a list of all farmers in Maharashtra if you are going for sampling framework. And this is usually something that you need. If you do not have, there are methods by which we can circumvent that. I'll discuss it in the next slide. Okay. So basically, sampling designs or methods can be classified into two. One is probability sampling and other is the non-probability sampling method. So in probability sampling method, what we know is the chances of a particular individual being selected into a sample is already known. That is, we can estimate it beforehand. Whereas in non-probability sampling method, this is not possible. Most of the cases we go for probability sampling methods because this will help us to probability sampling will help us to generalize about the general population. Like the results from the sample can be generalized to the total population. But in case of non-probability sampling, this chance is less. This is not there. You cannot generalize it to the common population, to the total population that we have. So first, let us look at non-probability sampling methods. There is convenience sampling, voluntary response sampling, purposive sampling, snowball sampling. So as you can see in the diagram here, convenience sampling, in this case, what we do is that whoever we find convenient, that is in this particular case, this person is closer to so and so people, so he gets data from these people. Okay. Then we have voluntary response sampling. This is something that you can do in the Zoom meeting itself when a teacher takes classes. So he can ask some questions, and those students who are responding, maybe those students, we can assume that they are more attentive to the class. Or same case, in this case, we can go to a village and ask whether which all which all farmers are willing to respond, and we can collect data from them. Okay. Now purposive sampling, in this case, based on some particular characteristic, we are taking collecting data from farmers. So maybe our objective is to look at how small farmers income is affected. So we purposively select some small farmers who have adopted a particular technology or who are having high incomes. So in that is purposive sampling. There is but there is no probability associated with it. And the third is snowball sampling, which is commonly something that we use when we go to places where we do not have any contacts. You find a farmer, you interact with him and ask him to give uh, contact details of few more people, few other farmers in that region. So you go to one farmer and he gives you contact of some other farmers and you go to them. So that is snowball sampling. So it is possibly this is correct. And even in some times when we conduct surveys, we are forced to do all these things. But these are not basically probability sampling methods, and our results that we get are not generalizable in this case. So whenever we go for a survey, we go for probability sampling methods where probability is attached so that we can generalize it to the population. So the simplest one is simple random sampling. So in simple random sampling, what we need is we need a sampling framework. Sampling framework is the list of all people or all sampling units, say farmers in the particular district or particular village we need. And what we do is, based on some random number table or which we can generate, we will take a random number table, and based on some values which we strike, we will select those farmers. So based on maybe we have a list of households, and based on the list of households, we'll randomly pick a particular household. In this case, what happens is that each individual in that particular population has an equal chance of being selected. Okay. So if we have 60 farmers in a locality and we want to select 3 farmers, so our probability will be 60C3. Based on that, we can get the probability of being selected in this. Okay. Now coming to systematic sampling. In this case, what we do is the first farmer is selected randomly. Am I audible?
Yes, sir.
So in systematic sampling,
Yes, sir.
what we do is we select the first farmer randomly, and after the first farmer, every kth farmer. For example, we will say every 5th household from the first selected household will be selected. So this is known as systematic sampling. This is this is commonly employed in used in case of sampling in forest. Like we want to take the height and girth of forest trees. So what they do is they select one tree randomly, and after that, every 10th or 50th tree, they go on selecting that. This is systematic sampling. Now, coming to stratified sampling, what happens is that maybe in a village there can be large farmers, small farmers belonging to different sizes, right? So what if we want to take the average land holding size of the village? Well, suppose we go for simple random sampling, like we are selecting 3 or 4 farmers. Here you can see let us say that the light green ones are large farmers. Okay. So when we select a sample, if we go for simple random sampling, there is equal chance that a small farmer is selected and a large farmer is selected. Equal chance. So if I am taking only 3 samples, suppose I'm taking only 3 samples and 3 of them happen to be large farmers, then the average size of holding in that village will be very high based on these 3 samples. If I go for simple random sampling, and sometimes these 3 farmers I take, suppose these 3 small farmers I get, in this case the average size will be very small. So this might not give a correct depiction. Okay. So what we do is we divide the farmers into strata, and farmers, each strata is homogeneous. So we divide the farmers into some groups based on some characteristics, and each strata will be homogeneous. And from each strata, we select some farmers. So that is what we do in stratified sampling. Now, how many farmers have to be selected from each strata? You can go for equal probability, equal chance selection. You can go for probability proportional to size selection, or you can go for name and allocation, where you look at the cost of sampling also in addition to the size of the population. Okay, there are 3 methods by which this stratified sampling can be done. Now, suppose there is a scenario wherein you do not have a sampling framework. For all these 3 methods, simple random sampling, systematic sampling, stratified sampling, we need a common sampling framework. Suppose you do not have the list of all farmers. Suppose your study is for Maharashtra, then it will be very difficult for you to get the list of every farmer in Maharashtra, farming household in Maharashtra. So what to do then? So what we do is we divide the total area into clusters. Clusters are heterogeneous in nature. Strata, which we discussed about, are homogeneous in nature. Clusters are heterogeneous in nature. And what we do is once we select a particular cluster, we enumerate it completely. So I'll just give an example. Suppose we want to get the list of mango farmers, vegetable farmers in a particular district. Okay. So in some districts there might be many vegetable farmers. In some districts there may be few vegetable farmers, and we do not have a list of vegetable farmers specifically. Maybe we have a list of all farmers. So what we do is we take one cluster, like one particular village, but we have a list of all the villages in that particular. A list of all villages is easily available, right? Compared to list of vegetable farmers. So we take one village as a cluster. And what we do is within that cluster, everyone we are enumerating. So basically you go to a village and every farmer in that village we are enumerating. And based on that cluster, in this case, one thing should be there, like cluster should be heterogeneous. It should not be like that villages, in some villages only our vegetable farmers are there. So in that case, we need to get a list of specifically vegetable growing villages, and a couple of villages you will go and you will select, or you will survey all the farmers in that particular village. So this is basically cluster sampling. Now there is another type of sampling called inverse sampling. Suppose our research problem is regarding the condition of migrant population. So getting a migrant might be very difficult in some places. So if you go for simple random sampling, it might be highly unlikely that there will be a good proportion of migrants in your sample if the trend of migration is very less in that region. Okay. So in case of inverse sampling, what we do is we go and select one particular migrant, go until we get one particular migrant farmer, and next we don't stop until the next migrant we are getting. So we have a specific characteristic which we are targeting, and until that character is not satisfied, we do not stop. So that is basically what we do in inverse sampling procedure. That is also a probability sampling, example of probability sampling. It is different from snowball sampling in the sense that here no probability is attached. In inverse sampling, you have a particular probability attached to it, and it is commonly used in case for like to estimate fish population. In those cases, on all inverse sampling is used. But in our research, basically, most of it would be simple random sampling, stratified sampling, cluster sampling, systematic sampling, etc. And we can also go for multi-stage sampling. For example, you are going for an all India level analysis. So from all India level, you can go for random sampling at the first stage, that is at the stage of the state, and then we can go for random sampling at the level of the district, and then again at the farmer level. Okay. Now coming to data collection, we can have secondary data, primary data. That is first major difference. Secondary data, it is collected for some other purpose and we are using it for our objective. And primary data, we are collecting ourselves with the specific objective in mind. Now, experiment versus surveys. In experiment, the difference is that you have control over many of the factors. Okay. In field experiments, especially, you have control over many of the factors, whereas in surveys, you have very limited control over factors. So in surveys, we basically try to infer about a relationship, whereas in experiments, what we do is we try to determine the relationship. Now, methods of data collection, broadly, we have observation method, personal interview, telephone interview, questionnaire, schedule, etc. So what is observation method? Observation method, what happens is in observation method, what happens is that we go to a particular village and we try to we do not ask questions. Basically, the researcher observes. He looks at things and he tries to get information from that. So what happens is there that one of the advantages is that subjective bias is removed. Then it has higher responsibility. Like if you have a schedule or use a personal interview, that person should be willing to respond to you. But in this case, this is not necessary. You can sit there and you can observe. And one of the advantages is that it can be an advantage as well as a disadvantage. You can only look at the current actions. You cannot look at the past or what has shaped these actions. If you are going for a survey and a person tells that he has not adopted the variety because he adopted it before and it did not give good results. So that particular case in survey, you can look at what has happened in the past and you can get relationship. But here it will lead to only current actions are involved. One of the limitations is that it is very expensive, because if you have to observe people, you have to stay there for a long period of time. If you go for 1 or 2 days, that doesn't count in an observation method. You have to stay there for weeks, months, or maybe even years. Then there might be other factors which might hinder our observation, which we do not have control over, which we haven't planned for. Okay. Observation method can be divided into structured and unstructured observation, participant observation, non-participant observation, controlled and uncontrolled observation. Structured observation in this case is that you have a specific plan in mind, like descriptive and exploratory studies. I will explain the difference between these using descriptive and exploratory studies. In descriptive studies, we go for structured observation, whereas in exploratory studies, we go for unstructured observation. Like I said earlier, you have a definite plan in mind when you have a descriptive study. You have a definite sampling design. You have a definite method through which you will be observing. All those things are there. Whereas in exploratory study, it is more or less unstructured in nature. Okay. Now we have participant versus non-participant observation. In this participant observation, what happens is that a researcher goes to a particular village. He tries to involve in every activity that the villager does. He becomes a part of the village and then he does that. Then he does his observation. This is what is being used commonly in ethnographic studies to some extent. You have people who go and who stay at villages and they try to get explore relationships or describe that village in that particular matter. One small disadvantage that participant method could have is that it could lead to subjectivity bias. Now, in a non-participant observation, a researcher just observes the action of the villagers. He does not become part of it. Non-participant method, what we have is we have objective method of study. This is commonly used in case of psychological research as well in this particular case. And you have controlled versus uncontrolled observation. In control observation, the person is kept in a controlled environment with certain factors. Certain factors are controlled, and then we make observations. Whereas in uncontrolled observation, it is done in the natural setting. For example, if you observe a villager in a natural setting, like if somebody who has a mental ailment or a physical ailment, like mental ailment, you try to observe him in his normal routine, then it is a, an uncontrolled observation. Whereas if you take him to a treatment center and there you try to observe his actions, then you might have some kind of controls over him. Okay. So that is what we call as controlled observation. Now, other thing is about collecting data. We might have telephonic interviews, and we can have personal interviews, and we could have focused group discussions. They are all methods of data collection. One thing I would like to highlight is that difference between a questionnaire and a schedule. This was asked to me in one interview. What is the difference between a questionnaire and a schedule? So the thing is, when you go for a personal interview, or you are the one filling that uh, uh, particular thing, then it is a schedule. Whereas in questionnaire, it is mailed to that particular person, and he fills it up and sends it back. So the questionnaire method is basically cheaper, whereas schedule is much more expensive. But in questionnaires, uh, the chance of non-response is very high, especially in COVID time. Now we have started using questionnaires because we have this Google Forms for data collection. We send that to a large number of farmers, and some of them respond, some of them don't. So that is an example of a questionnaire. And the second thing is, in many cases in the questionnaire, the identity of the respondent is not known, whereas in the schedule, the respondent might be known to you. Questionnaire is very time consuming. It is a very slow method, whereas in schedule you can do that much more quicker. So there is direct personal contact. And the thing is, in case of questionnaires, there can be a high degree of bias, or there are chances of misunderstanding their particular question. Whereas in schedule, the chances of misunderstanding the question is very less. Okay. So moving on to the next phase, that is data preparation. Now you have collected the data, you have raw data with you. Now you have to make it suitable for analysis. That is known as data preparation phase. So there are some key steps in data preparation. One is editing. Suppose we look at our questionnaire and we look at what are the errors and omissions that we have, and we try to correct that. That is the process of data editing. Data coding is the process by which we assign numerals or symbols to the data, and we try to categorize them. Now, data classification is categorizing data based on some specific characteristics. Okay. Example of data classification, you can have quantitative data where you can have intervals for classification, or based on attributes you can classify data. For example, we are looking at the income of farm households. You can classify it based on based on income intervals, maybe less than 4,000, 4,000 to 8,000, 8,000 to 12,000. So based on that, you can have different intervals, or you can classify it based on some other characteristics which are not quantifiable, basically, like whether it is a male headed household or a female headed household. So they are based on some attribute or some characteristic, whether it is male headed, female headed, whether it is belonging to a particular caste or not. Based on that, we can classify the data. Okay. Now, tabulation of data is a process of summarizing data and displaying the same in a compact format. So you have data, you need to present it in a very compact format, like summarizing, you have this descriptive statistics, right? Summarizing data that you will show the data in the form of a particular table. All your results are presented in the form of a table so that it can easily be uh, uh, understood. Now, the third step is data cleaning. Data cleaning is different from data editing because in cleaning, what we are looking at is we are looking at consistency. So, consistency means suppose you have a farmer, there is a drought in a particular region, and almost all farmers have reported very low yields. You find some farmers have reported very large yields. Okay, so we would check the data for consistency. Similarly, if you are looking at production, if a small farmer has a very large production value, which is almost similar to that of a large farmer, then we might have to check for consistency, whether the data is correct or not. That is what we are checking based on other observations that we have. Now, some cases we get no non-response. Farmers are not willing to give data on many characteristics. Maybe, for example, farm income. So what we do is the missing values we try to fill. One of the common techniques that we use is we take the average value of that entire population and you go for that. Now we have the third step, which is data adjusting. So in this case, one thing that we can do is like we give different weights to data given by particular kind of farmers based on our studies objective. Some kind of farmers are assumed to be more important than others, so we can give weights to them. Okay. This is something that we do in sampling. Again, what we do is post stratification. Once we have collected data, based on that, we will look at how many large farmers, small farmers are there, and then we are giving weights regarding that. Then variable respecification. So basically, this is you have many nominal variables in your data set, whether he is male or female, whether whether he is young or old, like that. We might have different nominal variables. So to subject them to quantitative analysis, we have to convert them into something called dummy variables. So that is a part of variable pre-specification. Now scale transformation. Now different variables of interest might be in different scales. So we might want to bring them to a similar scale to get comparison. So that is what we do in scale transformation. Now coming to the last part of my presentation, which is statistical inference. So I'll start with what is parameter and what is a statistic. Any characteristic of the population under condition, maybe it is the average income, maybe it's the average level of technology adoption, that is a parameter. Now we want to infer about that parameter from a sample. So within that sample, that particular characteristic is known as statistic. Okay. Now the third thing I want to familiarize with you is sampling distribution. Sampling distribution refers to all values of a particular statistic together with their relative frequencies. Okay. So there are two components. What are the possible values or particular values of that particular statistics, and what are the frequencies? They together constitute what is known as the sampling distribution. In many studies, we assume that the data is normally distributed, and that again depends upon the size of the sample that you have, or the size of the, mostly in the, when it comes to a population, we assume that it is normally distributed. Because in a large population, I'll come to that in my next slides in central limit here. And one term I want you to be familiar, you might already be familiar with standard error. So the standard deviation of a sample statistic is known as the standard error. So suppose your objective is to get the average yield of say wheat farmers in a particular taluk. Now what happens is, depending upon the sample you select, the average value might vary. So standard error is the standard deviation of that particular sample statistic under consideration. Okay. For example, If it is the sample mean, we have sigma by root n, where sigma is the standard deviation of that particular variable divided by the square root of the sample size. That is the standard error that is associated with it. So I'll come into the next slides on interval estimation. It will become more clear to you why the standard error is important. Okay. Now continuing to the central limit theorem. The central limit theorem is one of the most important theorems in statistics. Here, the central limit theorem is one of the is the basis on which many of the hypothesis testing we are doing is based on this particular central limit theorem. It states that the distribution of means of random samples taken from a population having mean mu and variance sigma square approaches a normal distribution with mean mu and variance sigma square by n as n approaches infinity. It means that as we try to go, we have a population and we have taken a sample from that population, but we do not know about the distribution of that particular population. But what it says is that if we take a random sample, the mean of those random samples, that the average of those random samples will be following a normal distribution as the number of samples taken increases. It means that if you have a large enough sample, as the sample size approaches infinity, if you have a large enough sample size, you can assume that the statistic, that is the mean which we are taking from the random sample, will follow a normal distribution. So what it does is it permits us to make an inference about sample statistic without knowing anything about the shape of the frequency distribution. Okay. Now, drawing inferences from probability sample about unknown population parameters is what is known as statistical inference. So based on a sample, we are drawing inference about the population in general. Now, point estimation. We have point estimation is a single valued estimation of a unknown parameter, but we can make many estimates of a particular parameter. So for a good point estimator, it should have 4 properties. One is unbiasedness. Unbiasedness means that if you take all possible samples from a population and you take the average of all these sample values, it will be equal to the average of the entire population. Okay. That is what is known as unbiasedness. It tells how much close to the true value our sample value is. Basically, suppose you have 10 farmers in a region. You take 3 farmers, you select 3 farmers, and you take all possible combinations of 3 farmers. Okay. And from each combination of 3 farmers, you take the average value of that particular farmer's income and you average it out again. Then what happens is that it will be equal to the average of all farmers selected. Am I clear here? Suppose you have can you just tell whether I'm clear in this one? Hello? Hello?
Yes, sir.
Okay, chat. Someone has asked. Yes. Okay. So this is the unbiasedness property. Now this is a normal property. We also have something known as consistency, which is a large sample property. It means that once the sample size becomes larger and larger or tends to infinity or tends closer to the population, the value of the estimator will approach its true value. Okay. Now the third is efficiency. Efficiency means the estimator which we are using should have the least variance. That is, it should have the least amount of variability. Then sufficiency means that, yeah, it is a little bit complicated in mathematical terms. So basically what happens in sufficiency condition is that all possible information from the sample has been used in the estimator. If you are given some additional information also, it might not help you in making a better in getting a better point estimate. So that is the sufficiency condition. So any good estimator will satisfy all these four properties. So I'll just give you an example. The sample mean is a unbiased estimator. It is an unbiased estimator of the population mean. But when you go for calculating the variance, we always, if it is taken from a sample of a population, we always go for 1 by n minus 1 into xi minus x bar whole square. Whereas for a population variance, it is always 1 by n into xi minus x bar whole square. Okay. So why we are using the n minus 1 is that if you go into Excel and go for variance command, you will have a sample and a population option coming there. So why we are doing this is because this 1 by n into x minus x bar whole square, it is not an unbiased estimate. If you take uh, if you take all possible combinations of 3 farmers from a total of 10 farmers, you calculate their variance and get the average of that. This particular value will be different from the variance average of variance of all farmers. Got it? So so when you are taking a variance of the entire population, basically, so you can try that out somewhere. I wanted to give an example, but I didn't. So that is one thing you have to keep in mind. Like that could be asked for exams, that particular formula. So now coming to the next one is interval estimation. Now what happens is that point estimates cannot be used to test hypothesis. So to test hypothesis, what we do is we get interval estimates. So interval estimate can be calculated. Suppose you have an unknown parameter theta, okay, and we have t, which is an unbiased point estimate. Now we want to get, if you change the sample repeatedly, the value of t could change. Like if you are getting the mean of mean from a sample, you get a point estimate there, but that value of the point estimate could change depending upon the units you have selected in your sample. So what we do is we go for an interval estimation. So what we do here is we need a confidence interval estimate, that is confidence coefficient, which we know which we call as alpha. Alpha, I will explain later, is the, you might know that this is the probability of probability of type 1 error. Now we need a critical value and a confidence coefficient. So what is this critical value? So this critical value is selected based on your sample size and your sampling distribution. So whether it is a t distribution, so based on t table, we check for the critical value and we multiply that with the standard error of our standard error of our design, or our standard error of the mean, or whatever standard error of theta. So we get a value called h, and then we have a range of values, that is t plus h or minus h. So theta is likely to fall within the range of t plus h and t minus h with a probability of 1 minus alpha. So you get a range where you could get the actual value or actual population, actual value of the parameter under consideration. It will be within a particular range. Okay. So I hope this part is clear. What we do is we take we take a critical value based on the distribution and the sample size. Then we go for multiply that with a standard error, and then we get a range within which theta could fall with a given probability, that is 1 minus alpha, where alpha is the probability of having a type 1 error. Okay, now hypothesis testing, this is the next stage. In this we have the following steps. First, we set up a hypothesis. Second is a significance level. Significance level is level of significance is basically the probability of having a type 1 error. Then test statistic. Test statistic is what we will be using to compare with the critical value, and based on that, we will make a particular decision. So in regression estimates, we don't always compare with test and critical value. We get another value known as p-value. I will explain that later. So most cases, if your test statistic is greater than a critical value, you reject the null hypothesis. So your hypothesis, you will be having two hypotheses. One is which we assume to be true, which is known as a null hypothesis. And then we have what is known as alternative hypothesis, which is that null hypothesis is not true, and we do not accept any hypothesis, we just reject. Okay, suppose we reject the null hypothesis or we reject the alternative hypothesis. Okay, the next thing is normally if the test statistic is greater than the critical value, we just reject the null hypothesis. Now looking at the type 1 and type 2 errors. So this is what happens if the null hypothesis is true and we reject that, it is known as type 1 error. Now type 2 error is accepting a false hypothesis. This is known as false negative. We reject a null hypothesis which is true. That is, we accept a null hypothesis which is not true, that is type 2 error. We reject a null hypothesis which is true, which is type 1 error. Okay. So based on the conditions we are having, either type 1 or type 2 error, which either of them might be more dangerous. And one thing about them is, if you decrease the probability of type 1 error, the probability of type 2 error increases. So there is a kind of trade-off between these two. So what we do is we generally fix one type of error, and in our experimental research or social science research, usually we fix the type 1 error, the probability of type 1 error as alpha, and then what we call as 1 minus beta, that is the power of the test, how strong our test is, that is 1 minus beta. Okay, where beta is the probability of type 2 error. So level of significance and test statistic. So level of significance is the probability of occurrence of a type 1 error. The test statistic is a number calculated from a statistical test of a hypothesis. For example, for t-test, we have a test statistic. It shows how closely your observed data matches the distribution expected under null hypothesis of that statistical test. Now, coming to how we accept or reject a hypothesis. So this is basically the non-critical region. If the tested value falls within this particular region, then we do not reject the null hypothesis. If it happens to fall in this particular region or this particular region, then we reject the null hypothesis. Okay. Then you can also have, this is a two-tailed test. You can have a one-tailed test. That is either if mu is greater than a particular value, greater than or equal to a particular value. So then it becomes one-tailed. If you have mu not equal to this, then it becomes two-tailed hypothesis. So there are many different tests of hypothesis. You have the t-test, you have the f-test. All these tests have a particular function. You can just remember those functions that could be asked in the exams. So that is all for my presentation. So if you have any doubts, I will be happy to clarify.
Participants, if you are having any doubts, you can ask. Can you read chat, sir? Or shall I read?
Okay, reference book. Okay, yeah, you can refer Kotari and Garg for research methodology. There they have covered all these research process in detail. Especially they have covered all the statistical tests also in a very simple manner. So it is. I'll just type it here. Research methodology by Kotari. I have shared the details of the book. So it is a very good book and it gives you a very good basic understanding of research methodology process. So that is the book that it is New Age International Publishers by New Age International Publishers. Now the new edition is also out. So there might be some updation in that as well. In addition to one of the advantages of this book is that in most of the books that we refer, especially economics, Gujarati and all, we do not have these canonical tests like principal component analysis, cluster analysis. That is not given in this book. Even that part has been covered. Okay. Okay, the scales part I am not very familiar with because I have not worked on scaling. I will just refer and get back to you. If you just drop your email ID, I will I will consult someone and get the details, and I will share that to you. So just drop the mail ID in the chat box. I will get back to you in a couple of days. I am not very uh, uh, competent in scale development basically. Is it the GL Rai book you are telling? Mondal and Ray. I'm not familiar with that book. Is it extension book, sir? Okay, extension. I am not familiar. Sorry. In this case, I'm from economics background basically, and around 5 years back I read extension. So right now I'm not very. I might not be. I might not be the best person to answer, but surely I can share a list of books for extension. I will share that with Sanjay sir or maybe Patil sir, and you can get those books. Okay. Uh, okay, sir.
Thank you so much, sir.
Okay.
Any other participants having any questions?
How to search a review of literature. So basically what you can do for searching review of literature is basically use the keywords, like whatever your research topic is, in that using keywords you can search in some database like Google Scholar, or you can use other databases like Scopus if your university have access to it. And key would be to use the keywords. And once you have got a research paper, just download the paper and just read its abstract. So once you read the abstract, you will have a general idea about what the research paper is or whether it is pertaining to your particular study. So in review of literature, you can do two things, as I mentioned there. One is to look at similar studies which have addressed a similar problem, and the other is to look at the theory that you have. Okay, the theories that are associated with it. For example, an extension, if adoption is there, based on the theory of adoption, you can review that. So you can formulate your questions based on that particular theory itself. Sir, could you please share these email IDs?
Yes,
Email
sir.
IDs, or what I'll do is whatever information I have, what
Yes.
I ask and get, I'll just share it to Patil
Yes,
sir,
sir.
and sir can communicate it to you, because or I'll just get a screenshot of these mail IDs. Either way, it would work out.
I will send you, sir. Okay.
Okay, sir.
Yes.
Thank you.
Or you can sir simply send to my email ID. I will share. I will share it
Okay,
to all
okay,
these peoples, or we will
okay,
post in group only.
okay, sir. Okay, sir.
Okay,
Thank
sir.
you.
Any participants having any doubts or questions? Okay, sir. Thank you so much, sir, for such a wonderful guidance. It was so much descriptive or knowledgeable. Thank you so much, sir. I extend hearty thanks to you on behalf of Department of Agriculture Extension and Communication, PJ MPKV Rahuri, for being here and guiding in such a wonderful way. Thank you so much, sir. Also, I express vote of thanks to respected faculty members. We are having here respected Dr. Gokul Waman, sir, Assistant Professor, Department of Agriculture Extension and Communication, PJ MPKV Rahuri, all the dignitaries, faculty members, and all the participants. Thank you, one and all. Thank you so much. In the afternoon, we are having another session. Topic is economic theory, including microeconomics and macroeconomics, and we will meet at 3 p.m. And the resource person will be Dr. Vikram Yogi, Assistant Professor, Department of Agriculture Economics, Agriculture University, Bikaner, Rajasthan. Thank you so much.
Thank you.
For the participant, attendance is posted in the chat box. Kindly fill that attendance form. In the afternoon, we are having the last session of the tutorial classes for the AICE-JRF SRB Ph.D. and ICAR-NET and ARS examination. Participants, those are interested to give their feedbacks, you can post your names here or in the WhatsApp group. We are going to start that validatory session near about at 5:15 p.m. Those participants want to give their feedback, can post their names. You can post your name in the WhatsApp group, or you can post here only, no problem. Participant from having subject agriculture extension as well as agriculture economics. Fill the attendance form if till you have not filled it. I'm just going to end this meeting. Those participants have filled that attendance link may leave meeting.